refresh button just because I didn't push it changed like a few minutes ago.
Okay, let's try that. Oops, sorry. We're ready to go.
Howdy. So my name is Mark Simmons. I'm a PhD candidate from UC San Diego, and I'm here to talk about results from a pipeline for transcribing bilingual elicitation using Whisper. So just a quick roadmap. So I'm going to start with some background information on automatic speech recognition, and as well as the tier language project, which is the source of data for this experiment. And I'm going to talk a bit about what the experimental goals are, how we created an ASR data set for our experiment, and go through our results. So first, a little bit of background. So automatic speech recognition should be fairly familiar to you after all the talks that we've had on the topic, but basically, I'm abbreviated to ASR. It's essentially refers to any technology for transcribing speech automatically. It can be used in voice assistants, automatic captioning, audio annotation. We're going to be talking about audio annotation specifically today, and so. Also want to give a bit of background on language documentation, which is probably beating a dead horse given the audience, but I want to have some definitions anyways. So language documentation is, Himmelman, 2008 defines it as a lasting multi-purpose record of a language. Language documentation can occur in the context of linguistic fieldwork in C2 or XC2. So linguistic fieldwork just referring to in the process of studying a language by interacting with the community, whether in situ being actually living and being present within the community's environment, or XC2 being more like remote fieldwork with diaspora speakers. In this presentation, I'll use the term fieldwork language to refer to a language which is being documented as part of a language documentation project. Now, there is an existing line of research for applying ASR for language documentation, as you can clearly tell from the talks that we've been hearing for the past 2 days. This is relevant because language documentation produces very large quantities of audio data that needs to be handled or annotated in some way. So this brings up the question of how can we use speech recognition to speed up this process of audio annotation. This is challenging because modern ASR systems are trained for high resource languages like English, Spanish, Mandarin, Russian, etc. So if we want to be able to apply automatic speech recognition technology in the language documentation context, we need to either train a new ASR model from scratch or fine-tune an existing ASR model using data from the given fieldwork language. I've included here some citations of prior work. There have been both work exploring training ASR models from scratch for ASR projects, as well as adapting existing foundation ASR models for fieldwork projects. In general, as far as I can tell, the literature that exists for automatic speech recognition in a fieldwork context focuses almost exclusively on the genre of data of monolingual narratives in the fieldwork language, as we've seen in some examples in the past 2 days. However, there is also ASR for conversational data in fieldwork language, but the one constant across literature on ASR in language documentation context is that it pretty much exclusively focuses on monolingual data in the fieldwork language. What can we do with data when we have fieldwork data that we're working with that isn't monolingual, though? One particular context where you might have a lot of fieldwork data that is not monolingual is the context of linguistic elicitation. So linguistic elicitation is it's a common method for essentially getting information, gathering data in a language. It, in essence, it consists of asking questions from language speakers. That the asking questions can be uh, eliciting translations of target words or sentences. Uh, it can be asking for grammaticality or felicity judgments. So say that as the linguist is trying to figure out the language, they might try to produce some sentence and ask a speaker, hey, does this sentence that I said, does it sound natural? Like when would I say it? Does it make sense in this context? Or you might say like, okay, given this one sentence in the language, like what are possible conversational responses I could give to this? How would this sentence be used in the context of a conversation? Um, Now, elicitation is often bilingual with a meta language used to prompt and study the fieldwork language. So this would be in the context where we have a linguistic field worker who is trying to study a fieldwork language. Yeah, and the linguist generally will not themselves be fluent in the language that they are studying, and so they need to interact with the speaker of the language and some other language that the two have in common, like English or Spanish or Russian. And so if we're and so if we want to so ASR for the context of bilingual elicitation has likely not received as much attention in the literature that exists on ASR for language documentation because to start out with, training ASR for bilingual audio is a lot more difficult in general than training ASR for monolingual audio. It's and so even outside of the field of language documentation, in the literature on ASR in general, monolingual ASR has received a lot more attention than bilingual ASR, just because bilingual ASR is much more challenging to handle. It's a bit more of an not really an edge case, but definitely like a more challenging than the standard monolingual case. Also, if we're thinking in terms of training data, when we're training ASR for a fieldwork project, we will likely have training data in the fieldwork language. So we will have monolingual training data, assuming that the fieldwork team is producing time-aligned annotations of speech in the fieldwork language. Fieldwork teams are generally not going to be spending time annotating speech that is in a meta language. So fieldwork teams are annotating recordings of elicitation sessions that are bilingual in English and a fieldwork language. They're probably not going to be making transcriptions of the English audio for that recording, and so they won't have data lying around that of transcribed English that could be used to the that could be used to directly train bilingual ASR. They'll only have existing training data for the fieldwork language. Likely, this is a generalization, obviously. And so, given these challenges that we have to overcome, is there some way we can use automatic speech recognition to help annotate this genre of bilingual data for language documentation? And so I want to give a bit of context for the model that we're going to be using in this experiment. So we're using the Whisper model, which is a open multilingual ASR model from OpenAI. It has achieved the state of the art metrics on several high resource languages such as English. Now, it's given that it is a multilingual audio. Whenever you're using Whisper to transcribe audio in some language, you can either specify ahead of time what language Whisper is seeing, or you can just let Whisper guess or figure out what language the audio is in. Whisper supports 99 different languages out of the box. And another advantage of Whisper is that Whisper handles transcribing speech, voice activity detection, so differentiating speech from silence and language identification, distinguishing audio in one language versus another. All of this is handled under one roof. So our task is to transcribe a long recording that has multiple languages and that has both speech and periods of silence. Then having one model that handles all of these problems all under the same roof, like simplifies our life a lot because we don't have to worry about creating a cascaded pipeline. Yeah. And another comment I want to make about Whisper is that Whisper was not trained out of the box to be able to handle code switched audio. However, given its multilinguality, Whisper does show some capacity to adapt to adapt to code switched audio. So Whisper was trained on 99 different languages, but for each language it was trained on, it only saw monolingual data in that language, generally speaking. However, some research has shown that if you give Whisper audio that is code switched between two languages that it already knows, it will show some ability to adapt. It will show some ability to recognize both languages simultaneously, even though it wasn't trained for code switching. Bilingual elicitation is not linguistically speaking code switching because there's a different communicative intent than there is in code switching. But for the genre of bilingual elicitation, we do see audio which is switching between two different languages, the meta language and the fieldwork language, in a pattern which in many ways resembles code switching. And so this raises the question: can we adapt Whisper to bilingual elicitation the way it can be adapted for code switching? So that brings us to the Tier language project. So Tier is a Kordofanian language of the Heiban group, spoken in the Nubian Mountains region in Sudan. Some notes on it. It's a very vital language with many native speakers. There's no sign of it ever dying out anytime soon, but there's also very, very little documentation that has been done on it. The Tier language project consists of linguists from UCSD and UC Berkeley that have been working with Tier consultant Hibadan Hassan from 2020 to 2024. We have been doing remote elicitation over Zoom, and then our consultant Himadan records our elicitation sessions using a microphone on his computer with Audacity. And elicitation covers topics such as lexical elicitation, exploring the inflectional and derivational morphology of Tira, exploring the tonal morphology and syntactic processes. And we use English as a meta language for elicitation of Tira. And so just to give an example of the kind of annotations that the Tira language project has produced that we can use for training. So we create time-aligned annotations of Tira sentences from our bilingual elicitation audios using Elon, and we transcribe Tira in a narrow transcription in the IPA. So you can see here's an example where for a demonstration I annotated both the English and the Tira. And the Tira turns in this conversation. So this is a sample conversation from bilingual elicitation where a linguist is asking, "Is this right, Himadan?" And Himadan says, "Yeah, that's right." And he repeats the Tira sentence that is the topic of study of this conversation. So normally the only thing that the Tira team the only annotations that we have from the Tira team would be this Tira sentence here. We wouldn't have this English here transcribed, and so we only have monolingual training data for Tira. And so we can use these Tira annotations that the team has already produced for training ASR and Tira, and we can hope that since Whisper is already very good at transcribing English, that maybe it's possible that we just train, or rather we fine-tune Whisper to recognize monolingual Tira and hope that it retains enough knowledge of how to transcribe English that when we later give it audio that is bilingual in English and Tira, it'll be able to adapt. It'll be able to handle this new bilingual audio because it says, okay, like I've heard all this monolingual audio in English. I've heard this monolingual audio in Tira. Now I'm hearing it both together. Maybe I can kind of maybe I know both enough about these two languages that it can be able to transcribe them both together. However, another question we'd like to ask is, even if the English portions of the audio were not annotated by hand, can we still use this audio in training in some way? Since Whisper is essentially state of the art for English, we can use Whisper itself without fine tuning to annotate English portions of elicitation audio and then use that for training. This process is known as data augmentation. And so, to briefly state our experimental questions, our first question is: when fine-tuned on Tira, how well does Whisper generalize to bilingual elicitation in Tira and in English? And does adding automatically transcribed English when training enable better generalization to bilingual elicitation than training on monolingual data alone? So our experimental process, first we organized our monolingual annotations for Tira into a training data set for ASR. Then we hand annotate 3 entire recordings for both Tira and English to use for testing. Then we generate machine labels for English training data. That's where we use Whisper to automatically annotate English from the recordings that's then used as training data. We train 2 models. The hand model is the model that is only seen hand labeled Tira, whereas the augmented model has seen both Tira and the augmented English training labels. And so a little bit about how we created the data set. So we had 9.5 hours of monolingual Tira data. We generated 42 hours of automatically transcribed English data during data augmentation. We tested the model on 3 data sets. So we had 1 hour of monolingual Tira audio set aside for testing, and then we have 2 recordings for bilingual data. We have these 2 recordings are I call them the in-domain and out-domain data sets. So in-domain refers to the Tira sentences that are contained within this bilingual recording were used during training. The English was not. So that means that the model that's trained only on Tira only sees Tira to begin with. The model that's trained on both Tira and augmented English, we skipped this recording for adding augmented English. That way, both models are being tested on Tira that they've already seen before, but in the context of English that they have not seen before. Then we have an out-of-domain. We annotated an out-of-domain recording where the model did not see any audio for either Tira or English during training. So just to help visualize what the process for data augmentation looked like. So first we took this is another example from Elon. So this top tier, this indicates what the annotations that we already had. These are the hand labeled annotations in Tira that the team app had already written. So we have here this is a sentence in Tira that was annotated by hand. Beneath this, this tier below shows indicates where we performed voice activity detection. So we essentially said, like, okay, let's use voice activity detection to find where in the audio do we have intervals of speech that have not been already annotated. Then we performed language identification, and I can talk a bit more offline about how we did language identification, but we used a model that took those regions of speech and identified them as either English or Tira, because not every Tira sentence had been annotated. And so for these sections of speech that have been detected as English, we used Whisper Large V2 to transcribe those, and then for the ones that were identified as Tira, we used the hand model, the model that was trained on monolingual Tira labels to transcribe those. And so then we take a bunch of these individual segments and concatenate them into a single training label, such that this entire sequence, like they will fetch water tomorrow, and then these 2 Tira sentences, this would all be put together as one code switched Tira in English training label. This whole sequence here would be a single utterance for the training set that the augmented model sees during training. Now, some limitations of using this method is the as I said, this pipeline well, since we have to use a pipeline approach to create this training data, it's very coarse and it misses a lot. And so like um I want to go through this fairly quickly. So basically a lot of tier words end up being mistranscribed as English because it doesn't perfectly segment tier from English, and so we see these instances of tier words being anglicized. We also see some common whisper failure modes where repetitions may only phrases that are repeated might be transcribed only once, or a single word might be repeated multiple times, or there might be entire sentences hallucinated. I won't go into this, but here are some examples of tier being anglicized. Um, and then here's an instance where an entire sentence was hallucinated, and in the training label, this is the kind of things that large language models do. So to discuss briefly how the training worked. So we fine-tune Whisper Large v3 with parameter efficient fine-tuning for 10 epochs. Then we evaluate with word and character error rate. Those are intuitively how many what percentage of words or characters are predicted predicted correctly. So a lower were and lower sir is better. So you can see here we have blue is the hand model trained only on monolingual data, and orange is the augmented model trained on bilingual data without augmentation. So we see here metrics on 3 different data sets. So the two in-domain and out-domain bilingual data sets and the monolingual tier data set. First thing I'd like to point our attention to is both of these models perform almost exactly the same when when tested on monolingual tier data. So takeaway from that is that by adding in augmented English to the training data set, we're not losing anything on Tira. We're not preventing the model from learning Tira by adding English during training. Uh, the augmented model, again in orange, has the best word error rate and character error rate for both of the bilingual data sets, and the hand model barely surpasses baseline in words, sir. Baseline being whisper without any fine tuning, and it for in domain, and then for out of domain, it's never better. We never achieve a better word or character error rate than whisper without any fine tuning. And so I'm pretty much out of time, but I do just want to give an example of output. And so here you can see that this is you can see that this is the ground truth label where we see this conversation alternating between English and Tira, and the model does correctly spot Tira in the context of English, with a few typos. But both the hand model and the augmented model seem to do well with this training label. But then one thing the augmented model does is that it does anglicize this one Tira morpheme. Whereas as opposed to the whole sentence was correctly reproduced in IPA. Another example. So here again we have an entire sentence with a bunch with English and then tier at the end. In this case, the hand model, the model trained only on Tira, all it produces is a Tira sentence. It just completely ignores all of the English in this entire recording. Whereas the augmented model does pretty good overall. It makes it like it changes I think so to thanks sir, and it says say it again Himedon to say they didn't have them, but it does pretty well with this code switched utterance. And so I have another example, but I'm not gonna go into that. In conclusion, fine-tuning Whisper on tier resulted in rapid overfitting on tier and catastrophic forgetting on English. However, if we add in automatically transcribe English during training, we prevent overfitting to tier, but we then add in errors where the model will anglicize tier because because of the coarse nature of the pipeline that we use to create data augmentation, where we were trained on these instances where tier sentences got anglicized because they were not correctly identified in the language identification step. And so some next directions are to create more informative and more informative evaluation than just using word error and character error rates, and primarily how can we clean up the data augmentation process. And I have and then also if we switch to a different pipeline other than Whisper, could we maybe not see as much hallucination? Thank you.
We have time for maybe one question.
So can you go back to the results like before fine-tuning in Epoch 0? Oh,
So before this,
results before fine-tuning, you have a figure around that?
oh, yeah, this one.
Yeah, so can you explain a bit more about this? Like if without fine-tuning, how the model performs on Tura?
Yes. So keep in mind that these two datasets, in domain and out domain, those are bilingual. Most of those are about 80 to 95% English. So the reason why so for this most of the audio is in English. So as we're so Whisper baseline can get a pretty good word and character error rates because it's recognizing the English portions of the bilingual audio correctly. Whereas you can see for what the tier monolingual data set, if we give Whisper baseline monolingual data in tier, it doesn't know what to do with it, and then word error rate. Like if I were to continue this line, I cut it off, but if I were to continue it, that would be around like 200% word error rate or something.
Yeah, so we have similar results. We have Whisper direct recognize the Gandhi data. The word error rate is above 250.
Mm-hmm.
Thank you.
Of course.
Time for a very short question. One question, short answer. Well, then, it's a more to add to your presentation, because we had the same thing. We had we had a lot of code switching in our corpus for the Sutine. And when I was training, first, intuition was okay, we need to fine tune on Dennis Sutine only. But then we realized quickly that we actually need to put all these recordings with code switching to the training data set. So it looks at, both languages simultaneously, even though it is pre-trained on English already. But yeah, it's just to add that we had similar results. It's better to just show it, but we'll see later.
Yeah.
Yeah.
Rolando, or I can talk to you offline if we're out of time. Yeah.
Thank you so much for the presentation. What do you think would happen in natural code switching? Did the system perform better for full sentences, for single lexemes? Did you see any patterns there?
So you do see so here for example like this here we see a single tier word is used in the context of an English sentence, and you can see that the augmented model is anglicizing this, but I think it's doing that because it saw English because of the nature of the training data it saw, whereas the model that's trained on monolingual Tira is transcribing that tier word not perfectly correctly, but pretty good, even though it's within an English sentence. And so I think if we cleaned up the training data, I think it would do. I expect the model will do pretty good at handling even more rapid intrasentential code switching.